No, I don't see the control to advance.
I mean that.
You sorry?
Okay.
It's okay. It's okay.
Do you have the controls, Aaron? Okay.
That's a thumbs up, so that's my cue to proceed. I'm pleased to introduce Cynthia DiCarlo, the W.H. Bill LeBlanc LSU Alumni Association Departmental Endowed Professorship of Early Childhood Education and Executive Director of the Early Childhood Education Laboratory Preschool at Louisiana State University, and Aaron Deris, Professor and Program Director of the Early Childhood Special Education Program School of Education at Minnesota State University in the United States. As you can see, the title, Impact of Technology versus Traditional Teaching Methods for Math Instruction in an Elementary Setting. Proceeding from a recognition of what I think is understood as the ubiquity of internet access and digital devices in the United States, as the presenters note, about 75%. This paper focuses on the impacts and applications of M-learning, the use of mobile devices to aid in student learning. The paper acknowledges the relationship between the use of devices of digital technology in education and increased engagement and learning, and turns its analytic sights, it seems to me as I read it, on M-learning and a comparison between the efficacies of this digital application and approach and traditional paper and pencil practice, a great term. It's my pleasure to turn the floor over to our presenters.
Thank you.
Okay, so what we're going to talk about today is an intervention study we conducted using single case research design, specifically alternating treatment design, to examine the impact of technology versus traditional teaching methods for math instruction. So 75% of homes in the United States have internet access and digital devices, which highlights that technology is now accessible to an increasing number of families and their children. In spite of recommendations from the American Academy of Pediatrics to limit screen time, professional organizations are recognizing that technology can promote effective learning if used intentionally. Increasingly, there's also a recognition that the integration of technology in the classroom should begin with pre-service preparation. Currently, teachers and school districts are struggling to determine the best ways to take advantage of children's interest in technological devices for enhanced learning. One such technology is M-learning, which refers to the use of mobile devices to aid in student learning. As has become clear with the onset of COVID-19 and the closing of schools and the mitigating of face-to-face teaching, there's both much promise and much development needed in the area of M-learning. The research question for this specific study sought to determine the effects of learning math concepts, specifically telling time, when using an iPad or paper and pencil worksheet. Specifically, we wanted to determine if children had greater attention and accuracy when using an iPad versus using paper and pencil practice on the same skill.
So for the methodology, the participants in the setting, the study was conducted in a public third grade classroom serving 23 children, with 13 boys and 10 girls. All the children were functioning within the normal limits of for their age according to a school district assessment. And at the onset of the study, the children age ranged from 8 years, 4 months to 9 years, 5 months. There were 4 male participants, Bill, Doug, Lucas, and Robert, and the children in the study scored less than 50% on a district-created telling time 1-minute assessment. Data were collected over the course of a 2-month period from March to May. The observations were video recorded in the classroom during the independent work time of the math block. Targeted children rotated between the 2 treatments of traditional paper and pencil practice, and then the M-learning, which was on the iPad mobile device, for a period of 10 minutes. And then the behavior definitions. For child attention, we focused on task and off-task behaviors. On-task was defined as engagement with independent math practice. Looking was defined as the child looking at the task, either the paper and pencil or the M-learning. And then manipulation was defined as interaction with a material using their hands. Off-task behavior was defined as lack of engagement with independent math practice. If the child looked at things other than the math practice materials, manipulating materials other than the math materials, he was considered off-task. This included getting up and leaving the math practice materials to engage in any other activity. A child was considered to be off-task if he looked away or ceased manipulation for a period of 15 seconds. And then correct completion was defined as the percentage that the child completed correctly during a session. For the intervention, as the focus of the study was telling time to the minute using digital and analog clocks, which was part of the state geometry and measurement standard of use of time, money, and temperature to solve real-world and mathematical problems, both the M-learning and paper-pencil practice focused on 1 minute telling time practice and reflected both reading a clock and drawing hands to the correct time. For the M-learning practice, the purpose of this study, the mobile technology was provided via digital application on an iPad, using a specific app called the Interactive Telling Time Learning to Tell Time is Fun. It was for an iPad and was used to provide children with independent practice on math skills. The process used to choose this application followed previous research recommendations, and this app was available on iTunes. For the paper and pencil, this was considered to be a traditional practice and was defined as the paper and pencil test that included but not limited to multiple choice tests, true-false tests, short answers, and essays. For our study, we used teacher-created worksheets that were created from a website for the independent math practice skills. And then interval recording was used to measure child's on-task behavior while engaged in independent math practice across both conditions. Data were recorded continuously using 15-second intervals. Partial interval recording was used to record on-task behavior, and whole interval recording was used to measure off-task behavior. Partial interval recording involved recording the occurrence of a discrete behavior when it happens at any time during the duration of a set interval, while the whole interval entails recording a behavior that has a long duration of occurrence, that is, the behavior consumes the entire interval. Inter-observer reliability checks were conducted on 20% of all observation sessions for each child. There were 40 sessions, so we had inter-observer reliability on 8 of those. Inter-observer reliability was calculated on an interval-by-interval basis and measured the number of times the research assistant and primary researcher agreed or disagreed. Inter-observer agreement for occurrences of on-task and off-task behavior was 97.5%, with a range of 80 to 100%.
Okay, so our results. For on-task behavior, comparisons across the M-learning practice and paper and pencil practice conditions were mixed. 2 children were observed to be more on task during the M-learning practice, and 2 children were observed to perform similarly across both conditions. For percentage of correctly completed problems, comparisons of accuracy across the M-learning practice and the paper and pencil practice conditions were also mixed. 2 children were observed to correctly complete more math problems using paper and pencil practice, and 2 children were observed to perform similarly across both conditions. The number of completed math problems. Comparisons between the M-learning practice and the paper and pencil practice showed that children completed more math problems during the paper and pencil condition as compared to the M-learning condition. On average, children completed 25 problems, ranged 21 to 33 problems, when using the paper and pencil practices as compared to children completing an average of 11 math problems, ranged 7 to 17 problems, when the M-learning condition was implemented.
For the discussion of our study, was it effective or versus efficiency? So effective use of mobile devices is dependent on the amount of time the teacher gives to researching the right app. guided practice with children, and allowing enough time to observe children using the actual device. Using technology in the classroom requires educators to understand the various apps used and how they correlate with daily lessons, as well as the connection between paper and pencil assessments and M-learning practice. And which is more efficient for young children, M-learning or paper and pencil? In the current study, children using M-learning practice were observed to be more on task compared to paper and pencil practice. However, children completed more math problems correctly using paper and pencil practice. With these mixed results, M-learning practice may be more effective in daily math practice, where paper and pencil may be more effective when time is limited or when a formative paper and pencil assessment is actually needed. And we also collected social validity or acceptability for our study. While children seem to enjoy the novelty of the iPad app, overall they stated a preference for the worksheets. This may be in part because of their history of learning through paper and pencil tasks. Being able to see problems seemed to have advantages for some children who stated that they felt they got more answers correct on the worksheet. However, one student complained at the number of pages in the worksheet packet. When using an iPad, children cannot determine the number of problems they got correct so far, or the number of problems remaining to complete. Depending on the child, this could be viewed as a positive or a negative. And there were, as always with research, limitations for our study as well. So one limitation of this current study is that may have been that the study was conducted at the end of the school year or the fourth quarter, when focusing on schoolwork may be additionally challenging for children. Additionally, the study ceased when the standardized testing for the school began, as teachers focused on the testing. And then as children were exposed to technology on a regular basis with frequent access to both iPads and Chromebooks in the classroom, often daily, this could be considered a limitation. M-learning was not novel and was part of their normal learning environment. Perhaps if children were not exposed to technology in the classroom regularly, then they may have performed differently. And then another limitation of this study is all 4 children knew that they were actually being videotaped, and perhaps were more on task due to the fact that they knew they were being recorded, and eventually the data would be used in a study. The iPhone that recorded each video was placed about 4 feet away, but remained in view. Perhaps if the recording device was on the opposite side of the classroom, the children may have been less aware and may have changed their actual behavior. Additionally, the M-learning app required time to load each problem. If the app was quicker, children may have completed more problems. The M-learning math app took between 12 to 15 seconds for the digital clocks to stop spinning for each problem. Children then took about 10 to 15 seconds to select an hour hand using a scrolling number dial, and 10 to 15 seconds to select the minute hand using a different number dial. Finally, the study examined the use of only one mobile application, which was the interactive Telling Time Learning to Tell Time is Fun app, and compared its use to paper and pencil practice. Our findings are limited in that we focused on only that one particular application. And then with all of research, there's always items to consider for the future. So some suggestions for the future would be replicating the current study with a variety of genders and math subject content. As we stated earlier, all of the subjects were male. It is unknown if there might be differences in regard to female students and their responses to the actual intervention. Also, as noted earlier, the research was conducted in the natural environment, and the study ceased when standardized testing began. During this period, all instruction and time were focused on preparing for the standardized testing. Future research is needed to determine if greater differences might be found in the study for a longer duration. Oops. Now, open for questions.
Thank you. As Aaron has just noted, we'll take questions and comments from the floor. Or feel free to enter it in the chat. And there are some comments forthcoming, as you can see. I'll ask a question to get started. Presumptuous of me because this is so outside my area, but I'm really curious as to your own research curiosity. And by that, I simply mean, can you extrapolate these results, the discussion and conclusions, beyond the discrete case of math instruction? Is this very specific to math instruction? Not running experiments like this myself, I'm interested in the big question, and the big question for me would certainly be, can this be extrapolated? Are you looking at that? Is this, or is this the results that you found limited is the wrong word, focused on math instruction?
I'll take that one. I'll crack at it first anyway, Aaron. So in previous research that we have done, one of the things and so the children did all complete more problems with paper and pencil. And so sometimes that ends up being an issue with technology in general. So it may be that, if your child's playing with a VTech toy or something, the technology will give feedback, and it'll almost, thwart a child participating because it gives so much feedback. And so in this particular sense, with the iPad app that we used, it took a little bit of time to load. And so, that can, cut into the time that children have available for independent practice and moving toward working through problems, which certainly wouldn't be specific just to math instruction. We actually did a study a few years ago with a reading app, very introductory level with preschool age children, and we found something very similar. So I think that can also get in the way.
Okay. Thank you. There are two questions. One from Deb. Could the students have gotten used to the iPads prior to this observation and also being observed prior to this?
Yeah, so Deb, I think I understand the question, and so the answer that I'm going to give, and correct or jump in if I'm off base here, but the classroom that we used did have a number of opportunities to use technology before and after this particular study was done. So that's why we thought that was possibly one limitation, is that they already did have a lot of use with that. They were all four boys thought it was really cool that they were being videotaped. And so I'm not quite sure. I guess we could have probably put a video camera in there and done something a couple weeks ahead of time, and that way maybe they would have known, or we could have said that you won't be always videotaped, but always left it on, and that way they didn't know what was going on and when it was going on. So that could have possibly helped as well. So chime in if I misunderstood that. And then for Mona, you had asked, what explanation do you have for the significant lower number of exercises done using the technology, besides just the fact that it took longer for it to actually load?
Now, we didn't time, I'm not remembering if we timed this. I think we did. We did have load time, but another issue that happens with technology that is a little bit different than paper and pencil, if you've ever interacted with an app, when you get something correct, there's a little bit of fanfare that happens. And so that takes up time too. So you get that feedback, which in a way is a good thing, right? Because, you're doing the child's doing something on the app and they're getting reinforcement for performing in a certain way, but that also reduces the amount of time that they can move through problems.
Thank you. There's one other question that we should entertain from Mona Lisa again. Other than the time taking to load up the exercises and to maneuver the clocks online, what explanation do you have for the significant lower number of exercises done using the technology? I'm somewhat surprised by the results, as I would have expected to be different.
That's kind of what I was getting into a minute ago, because the feedback that the children receive, in between problems or in between categories of problems, the app has like a little transition cartoon or a little bit of feedback that that cuts into the amount of time that's available to answer the problems.
And Mona, I would say we were also surprised by the results. We thought ahead of time that they would have been rock stars, if you will, on the app, and that the app was going to win out, and that paper pencil traditional assessment and traditional skill would not have been the one. There wouldn't have been mixed results at all. We thought for sure that the app was going to be the be all end all with kids with technology.
And really what was interesting to me is the social acceptability data, because I think since the children were so used to using maybe technology at home for play, they tended to think that the paper and pencil was like work, which, you know, we could definitely use in order to get them to have more independent practice on that device. But they seem to prefer that for that paper and pencil for that reason, even though they did, many of them play longer or interact longer on the M-Learning device.
Great. Thank you very much. Applause. Thanks. Okay. I'll ask Roberta. There is by the program one more presentation.
No,
but I'm not sure.
Coleman had a personal problem, so he's not able to join us, unfortunately. So we can.
That's why. Sorry.
Oh, sorry.
That's why I'm asking, because I didn't see Hardin's presence in the participant list. So we'll close the session.
Yeah, and let's meet together in the other room, the closing speech, and it was going to start in 7 minutes. And in the meanwhile, Martin, many thanks for helping us in moderating this session. It was definitely a great session, and thank you everybody for your presentation.
I thank you so much, Roberta, as always being stalwart and solid foundation for these things. And to everyone who was in attendance, and especially to Joseph, to Chen, to Deborah, to Alana, to Cynthia, and Erin, thank you very much for an enlightening and very productive session. And we'll see you in person next year, for sure.
We hope so. We really hope so.
Okay. Cheers.
Cheers.
You are now muted. You are now unmuted.
Buongiorno. I can't hear.
You are now muted.
Should I go and come back?